Hey, welcome back. This is the 3-jaw chuck that came with my with the MCO Super 11 lathe. It's a standard 3-jaw chuck with integral D1-3 short taper nose. So this fits directly on the spindle of my lathe, which is quite nice. But I don't have any need for a regular 3-jaw with hard jaws. I have the 6-jaw, which is adjustable, and that satisfies all my chucking needs on the lathe for a scroll chuck. But stupid me sold his soft jaw chuck with his old lathe. I had a inexpensive 3-jaw chuck that came with my old lathe. Had a set of master jaws for it, and I made a bunch of pie jaws like this set here for it. And when I sold the lathe, I gave the chuck away with it because it belonged to the lathe. But I forgot that I have recurring work that needs a soft jaw chuck. So I need to do something. This 3-jaw here, this MCO 3-jaw chuck, has only the external stepped jaws. The jaws that are stepped the other way to hold large discs and stuff like that are missing. So even the resale value is relatively low because one set of jaws is missing. It's in very good shape. Side-to-side play of the jaws is minimal. So everything's very tight on it. So what I was thinking, I'm going to machine down. This is sacrilege, probably. I'm going to machine down the jaws flat, machine a keyway in it and a spline, so the soft jaws register on it. That way, I get a soft jaw chuck out of this MCO chuck, which is very short, which is nice. Has the integral mount, and otherwise I would never use this chuck for anything, because why should I if I have the 6-jaw, which is way better with the hard jaws. With the soft jaws, this will be a very good chuck. So we probably have to take these jaws and anneal them, put them in the oven at maybe 500 degrees C, let them soak through, then we can machine them. These I gave it a shot with a file, and these are hard. Don't do this with a good file. Use a file that has already streaks in it and is damaged beyond salvage. But yeah, these jaws are rock hard. So we will throw them in the oven. We will draw them back to maybe 4. The problem is I do not know which kind of steel this is. This is probably just a carbon steel with a very decent heat treat. So drawing it back shouldn't be a problem. These are probably not air hardening tool steel or something crazy. So drop them in the oven. I will look up a carbon steel data sheet and give it some, and find the right temperature to anneal it to maybe 44-40 Rockwell C. I would prefer not to make them completely soft, and I don't want to reharden them. Rehardening is a problem if you do not know which steel it is. You might burn it up, just a lot of problems. You saw me annealing those back to about 40 HRC, and with a good quality file I can now file them. They are still really hard. 40 to 44 Rockwell is still very tough. check them with the hardness test files. The 40 Rockwell C file grabs ever so slightly. So seems like we hit our hardness target pretty good. Now we'll see if I can bandsaw this excess material off, otherwise I have to mill it off. Might be too hard to bandsaw. I put it into CAD, drew up the jaw, and this is what we're going to make. We will remove material on both sides to create a key, almost like a key or a spline in the middle, and a cross slot that the jaw can register, so it's always in the same position. And of course 2 holes threaded M6 to hold the jaws down. I barely can bandsaw it. It's really right at the edge of being sawable with a normal bimetal bandsaw blade. Going relatively slow so I don't burn up the blade. This is not a new blade anyway. I don't want to burn up a new blade in something that hard. So this works quite well. Got rid of all the excess jaws. There we go. Next off, surface grinder to clean off the top. That was a bit much material to grind off. That was an average 1.5 millimeter. So I took a 6mm carbide end mill to it and plowed off most of the material. So now we'll clean up it on the grinder and go from there. And checking with this mic, we are reasonably close. One of the jaws didn't completely clean up in this edge here for some reason, but this will fall away when I mill the central spline anyway. Okay, I roughed away most of the material now. Just full depth cut, almost full depth cut, slotting away all the material, and then coming back and doing a semi-finishing pass. I will use a smaller end mill to cut the relief in here, and also to finish the key here, the spline in the center, to finish this to final dimension. This face here will be surface ground. You just saw me using a 2mm carbide end mill to finish this spline to final width, and also cutting a tiny relief in here. I went down about 0.2 millimeters. I have 0.05 millimeter or so grinding lines on this face here, so this tiny relief in back here will be enough. And that's pretty much what I was aiming for, slightly below 8 millimeters. Roughing out the key slot with the same 6mm carbide end mill that we used before to rough out the steps here. This end mill is pretty much gone. I used this the other day to rough out the huge number of parts in cast iron, and it's reaching the end of its life. So using this to hog out the material, the majority of it, and then I will switch to a good one, a new end mill, to finish it to final width. I have the parallel sprung apart with a coil spring and my stop here, so it's a relatively repeatable setup for what we're doing here. I'm going to take a full slotting cut and then I will step over. All the heavy roughing is done now. Now we switch to an end mill that's a little bit better than this one. Okay, use the new 6mm carbide end mill to clean up the slot, and it's a decent fit on a 12mm gauge block. So last thing machining wise or mill wise is to drill and tap the M6 holes to mount the soft jaws. This is one of the rare occasions where I do not dare to power tap these. These are still relatively hard. It's blind hole, so you don't have to risk it. Using a little bit of cutting oil, and I use my ratchet on top of the drawbar. I use the ratchet on the hex of the drawbar to drive my spindle that I put in neutral. That way I have the accuracy of the mill, but I can relatively sensitive do my tapping by hand. It takes forever. Power tapping is really the civilized way to go, but in this case, not exactly sure. And to get it out, I can use motor power. We need to talk about the grinding I did at the beginning. That didn't exactly work out. I had the part sitting on the back of the teeth of the jaws and I ground the top surface. When I put the jaws back in the chuck body and I checked if the jaws are flat and parallel to the back side of the chuck, I had an error of roughly 0.02 millimeters. Not the end of the world, but I wasn't happy with it. So what I did, obviously that meant that the slot that guides the jaw in the chuck body was not perfectly true to the back side of the teeth, which is fine, but didn't realize that at the time. What I did then, I put the jaws back in the chuck. I dropped the chuck on the surface grinder, and I ground the top, and I preloaded it in the center ever so slightly by clamping a bushing, so everything was slightly tensioned, and then I ground the top again. And then I was sure that the top surface of the jaws is always parallel to the back side of the chuck. And then I flipped the jaws around and I dusted off the back side of the teeth, just so this is a known good reference surface when I machined the front surface here. Then I went ahead and I, as you saw, milled out the slots, the cross slot here, and drilled and tapped it. And now I can go back, drop it on the magnetic chuck just like this, and grind these faces here. And then these faces will be perfectly parallel to the back side of the chuck. It's all not super critical because you machine the chuck jaws in place on the chuck, but still I want just to do a proper job. I want to have it as good as I can do it. Last thing that makes it look like €1,000,000, sanding sponge. Sanding sponge attacks mostly the edges and corners and just gives it that last little bit of attention. I buy them relatively cheap, either the nail polish sanding blocks or sanding sponges, or these are woodworker sanding sponges. And they don't really last a long time. They wear down quite fast. Especially if you're a little bit clumsy like me and you tear into the foam. Then their days are basically counted. I could do a deburring podcast where I just sit there, deburr, and tell you stories. Got the chuck with a set of old pie jaws. These are segmented jaws that are almost a full circle, especially useful for plastic parts. Got it preloaded here on the bottom with a piece of round Delrin clamping on the master jaws, and I'm using a large DCMT boring bar to get this to final size. So I can hold this and bore it out to a very thin wall. And that's one of the cases where the guard around the chuck is relatively nice, because between the segments of the soft jaws, a lot of chips get flinged out in your face or in the shop, and you have to clean it. And as I like to run a clean shop, if I can prevent dirt, then all is good. 110, and then I need to bore it to 100 and... There we go. That's the chuck jaws bored to final diameter. Now we can take out the preload piece and see if we can get a nice hole. Oh. Yep, that's fairly secure. No worries with the setup that the part will come out. And I have to do a fair number of these parts, so boring a set of soft jaws is a no-brainer. Last step is to drag the die grinder over and deburr all the sharp edges. Quick visit on the surface plate. I have a 0.01mm interrapid dial test indicator here in a surface gauge, and I have the 3 jaw with the master jaws, and I put a little bit of preload on it so the jaws do not weeble wobble around. And we're going to check the facial runout of these flats, which are 4 per jaw. If those are all parallel to the back side of the chuck. These surfaces are where the jaws rest on. As I said before, it's not super critical because you cut the jaws in place anyway, but do it properly. So let's start here. I already zeroed out the indicator, more or less. So let's say this is 0 here. This is plus plus 10 microns, 0, plus 10. Let's go to the next one. 0. And, ugh, almost 0. So, what do we get from this? I have no idea. Plus 10, plus 10. It's all slightly in plus. So the middle is plus 10. Or it's basically plus minus 0.01 millimeter from the average height. Plus minus 10 microns. That's pretty okay. This is still just a chuck, and these are free to move until they are clamped down. That's the reason why you always should use the same pinion if you want to do precision work with a soft jaw chuck. There is one pinion on your chuck that's marked, and normally the zero mark does not really say anything. It just marks the pinion that was used to preload the jaws when the hard jaws were bored. If you're working with soft jaws, you can use each one of these, but you should always use the same one. Most easy is just to use the one with the 0, because that's the easiest to remember. Hope you enjoyed this, what we did to this chuck. Thank you all for watching, and see you next time.